Hello students, welcome to the first video in the first module of this course. The title of the module is Angles and Trigonometric Functions. So we will first study the angles. We will talk about two different systems of measurements of angle, namely the degrees and the radians. And we will talk about the concept of positive and negative angles, the concept of clockwise and counterclockwise rotation, and we will talk about how to convert from one system to the other system, and how to divide the angle into minutes and seconds, degree into minutes and seconds, and all arithmetic and algebra related to that. And once we understand angles thoroughly, we will look at the first definitions of the trigonometric functions, and we will evaluate, and the values of the trigonometric functions for some angles called standard angles. Standard angles. Okay. So let me begin. In the first module, the first topic is angles and degree measure. So what is an angle? Given two rays with a common endpoint, that is, you have a ray here and another ray here, and their endpoint, right? A ray has one endpoint and then it continues to infinity on the other side. So say this endpoint is A. Given two rays with a common endpoint called the vertex. Now this endpoint, the common point, will be called the vertex of the angle. The measure of the, so what are we measuring now? If I start from this ray, anyone, and rotate up to the second ray, right? So we are measuring some concept here, right? How much I'm rotating. So the measure of the rotation between the two rays, or the amount of, okay, actually I should have used the word rotation in the second blank. The amount of rotation needed to map the measure of opening. So these are all different words, as you can see, we are trying to use to intuitively make the concept of an angle clear. Okay, so the measure of opening between these two rays, like how much opening is there, right? Is it narrow or wide? We talk about narrow opening or wide opening. Or what is the amount of rotation you need to start at one ray and reach the other ray? Okay, so where you start will be called the initial ray. Could be any one of them. Okay, let's say this is B and this is C. Suppose, the AB is your initial ray, and starting from there, you rotate up to AC, which is your terminal ray. From the initial ray onto the terminal ray, it's called the angle between the rays. Okay, basic definition of angle, right? And what is the notation? We often use this notation for angles. Okay, so this angle with this cut, that is the notation for angles. Okay, so we'll call it angle A here, or you'll see that sometimes it is given the full name, angle CAB. Okay, that is to say, the two rays are AC and AB. So we say angle CAB with the middle letter being the angle, the vertex. Okay. Clearly, there are two angles between a pair of rays, because if you look at this diagram here, you might say, why do I have to rotate like that? I could have gone around like this, right? You could have rotated the other way and reached the same terminal ray. So for both these angles, the initial ray and the terminal ray are the same, right? So there are two angles between these two rays, depending on what sense of rotation is followed. Sense of rotation. Okay, now we're talking about the sense. Did I go like this or did I go like that? Now, I can show you like that, if I'm teaching you on the video, if you are seeing me on the top right, top left. But the formal word for that would be clockwise, because then it becomes standard, right? Or counterclockwise. Okay. So if you are going, clockwise, now it becomes standard for all of us. If you are going in the direction of the rotation of the hands of the clock, clockwise or counterclockwise. In this case, this would be counterclockwise. The smaller angle here is counterclockwise, and the bigger angle is clockwise. Because we said that, AB is our initial ray, and AC is the terminal ray. Okay, so counterclockwise, clockwise, right? Okay, so we studied the definition of angle, and we talked about the idea that between any two rays, there are two angles, measured clockwise and anti-clockwise. So obviously, now if we need to develop a common language to talk about angles, we need to have some standardization, right? So everybody speaks and understands the same concept, the same meaning. Everybody interprets the same way. That is obtained, that goal is obtained by defining what we call the standard position of an angle. Okay. Now, in the standard position, we use this coordinate system. What you are seeing here below, the two diagrams, these are two coordinate systems, right? The rectangular coordinate system. Okay. The x-axis and y-axis. And in the standard position, we make sure that the vertex of that angle is at the origin of that coordinate system, which is where the two axes meet. So the O will be the vertex of the angle in the standard position, and the initial side or ray, is by default x-axis. Okay, but I'm going to put an adjective in front of that. Positive x-axis. What does that mean? Starting from origin, we moved right. That is positive x-axis. So that will be your initial ray. Vertex at origin, initial ray towards positive x-axis. And then you measure the angle. Okay. That would be called, so that would be, if you place the angle like that, you will call it the standard position. Now, of course, you could start from there and go clockwise or counterclockwise, right? Let's say I went like this, counterclockwise, and we'll talk about the measurement systems later. Let's say this is 30 degree. Okay, we'll shortly talk about the degree and radians. Then the convention now, see, you could go 30 degree like that, counterclockwise, and reach that terminal ray, or you could start on the positive x-axis here, right? And you could go clockwise. How much? 330 degree. Okay, we'll talk about again, as I said, about that later. So you could go 30 degree clockwise or 330 degree sorry, 30-degree counterclockwise or 330-degree clockwise, and come to the same terminal ray. So that means, of course, now we have to talk about, you have to distinguish between these two, right? And we want to not use words, we want to use symbols and make it easy, right? We introduce the concept of positive and negative angles. So you will say the measurement is positive if you measure it counterclockwise. The way I remember this is counterintuitive. Okay, if you go counterclockwise, it is positive. If you go clockwise, it is negative. So which means on the left side, you would call it 30-degree. That's correct. On the right side, I had to edit. I had to put a minus sign there. If you go clockwise, you measure it as negative angle. Okay. Negative angle is measured clockwise. Right. Okay. One more, just to illustrate and give you the idea. Maybe in a different quadrant, right? Let's say you are here, and you could measure that here like that and call it 135-degree. Okay, x is here, y axis here, or would go round like that clockwise and call it negative 225-degree. Okay, positive, negative. That's clear. Okay. Now we are of course going to talk about special angles. Actually, in fact, the two angles that you have seen so far are what we call standard angles when we go to trigonometry. Okay, 30-degree, 45-degree, or their multiples, right? 135 is 45 times 3. You want to think about it. Okay, so these are standard angles. Some more, like even more standard angles are what we call quadrantal angles. Okay, this is the concept is related to what we call quadrants. Maybe I'll talk about that briefly. When we, this is a review. Okay, you have studied this in college algebra. You have the first quadrant in the positive x, positive y. Then you go counterclockwise, right? Second quadrant, third quadrant, and fourth quadrant. Okay, so in that sense, you would say the 30-degree here or negative 330-degree is in the first quadrant, right? The 135-degree here is in the second quadrant. What if you have the angle on one of the axes? Take this angle, for example. Okay, if you measure it counterclockwise, you will call it 90-degree. Okay, so these are angles whose terminal side is on one of the axes. Okay, remember in the standard position, the initial side is always the positive x-axis. If the terminal side is one of the axes, that means positive x-axis or negative x-axis or positive y-axis or negative y-axis. We call it quadrantal angles. Okay, that is positive x-axis. Okay, positive or negative. I'm writing plus minus to indicate positive or negative y-axis. Okay, so I can list them here. Actually, what are going to be the quadrantal angles? They will be 90-degree, 180 degree in degrees, 270 degree, and then when you complete the whole thing, it will be 360 degree. Okay, here 90 degree, 180 degree. This is counterclockwise. Okay, measured counterclockwise, 270 degree, and back here that will be 360 degree, which is the same as 0 degree by the way. Okay, another concept we will be talking about in detail later also. Okay, these are the quadrantal angles. Okay, so a lot of like in this, like first few in every lesson, first initially we study the definitions and all the basic terminology, right? We are going through that. Okay, coterminal angles. Now the name you can see co, so that means same, right? They have the same terminal. What terminal? The ray or the side. Okay, so if two angles have the same terminal side, you call them coterminal. Angles that have the same terminal ray or side. Okay. Note that in standard position, all angles have the same initial side, which is the x-axis. Positive x-axis actually, I should say. Plus VE means positive. Okay. So the positive x-axis is the initial side for all of them anyways. If the terminal side also is same, we call them coterminal. So here is an example. Okay, then I will ask that question, what you see there highlighted. If I am measuring 0 degree, I could measure like this. That's my 0 degree. I'm not labeling X and Y. You understand by default, okay? All of them. Like, when you do it, make sure to always write the labels X and Y in every graph, okay? I'm putting the disclaimer and doing it. Okay, so let me write that here. X-axis is here, and this is 0 degree, right? But you could start from there and make one full rotation, and that would be the same angle would be your 360 degree. 0 degree and back 360 degree is the same direction. So they have the same initial ray, of course, and also the same terminal ray, right? So graphically, if you see, it's the same angle. Okay. So the question we ask is, aren't coterminal angles the same? And the answer is yes and no. Okay. They are the same, of course. If you look at, if they point to the same direction, they have the same initial ray. So everything is same. Then why did they say yes and no? That's because when you are doing it analytically, when you are seeing, sometimes when you write it, like when I write 0 degree and 360 degree, I'm writing different numbers, right? So a better word is, instead of same in mathematics, we use this word equivalent. It's somewhat related to equivalue. Their value is the same. Okay, they're similar concept. Like we say synonyms in the language, English language, right? Two different words, but they have the same meaning, right? We call it synonymous. Similar idea here. Okay. All right. So here is 30 degree, and what I want you to do is to sketch that 30 degree and find here, here there's a blank space. Find another angle which is coterminal to 30 degree. Okay. So this is 30 degree. Previously, I did the negative one. negative 330 degree, which is fine, which is coterminal. But this time, let me do different. Okay, so 30 degree, and I'm going to make another rotation on full rotation. So what would I call it? If this is 30 degree, when you measure the first time, what would the value be after you make another full turn? And you must have guessed correctly, it will be 390 degree. Note that I'm doing counterclockwise rotation. Okay. And now you are seeing this another idea, right? That you could do more than one full circle rotation. And in fact, you can go round and round. Okay. Your values, the angle will become larger and larger, but those are all going to be coterminal or equivalent angles. Every time you add 360 degree or subtract 360 degree, that is, if you go full circle clockwise or anti-clockwise, you come back to the same angle, right? Okay. In general, an angle theta, okay, this is a Greek letter, this is read as theta. Very soon we are going to look at all other Greek letters as well, is coterminal with any angle of the form theta plus and minus 360 degree, right? But not just 360 degree, k times 360 degree. Okay, k times 360 degree, where k is an integer. So you could add 360 degree once or twice, or you could subtract once or twice, or so on. All those angles would be coterminal. One basic fundamental concept in measurement of angles. Okay, so we did discuss many ideas about angles. Before we do some practice problems, here is a list of these Greek letters that we use in trigonometry a lot. Okay, so I thought, I will go over them with you. So in future, whenever I talk about it, you don't feel alienated. Okay, or you don't think that I'm talking some alien language. Okay, so alpha. Actually, many of our English letters, in the English alphabet, the letters, they have their origins or their roots in this Greek and Latin letters. Okay, alpha is, I'm writing it in my way here. Okay, but you have to look at the symbols in the book also. Okay, the more standard symbols will be there. So alpha is like is the first actually alphabet in the Greek, first letter in the Greek alphabet. A comes from alpha, right? Alpha. And then the second one there is beta. And you can see B comes from beta. Not everything comes from these letters, okay, but most of them. And then gamma looks like Y, okay, that's gamma, but it's not Y, okay, that curve, that's gamma. Theta that we saw just now. Phi is this like 0 with this cut, okay. Phi. Mu, it's like U, but with that extra tail on the left. Nu, how do I write it? Looks like a V. Okay, so basically V in Greek is no. I don't think I did a good job there. Again, you see some print versions. Okay, Xi. omega, which is the root for the letter W, I think, omega. Like we say A to Z in English, in Greek you say alpha to omega. Okay, I guess that's the last letter in that alphabet. Lambda. And these are all small cases, by the way. Okay, what I'm writing here are small cases of the Greek alphabet. They have their corresponding, I think, capital cases. Okay. Delta. You can say it's a precursor to D, delta. Kappa is the precursor to K. Eta looks like N, but with a longer N there. Okay, and there are more. And not that we are going to use all of them all the time. You will very commonly see alpha, beta, theta, I would say omega. These are very commonly used. And once here and there, you will find these other Greek letters also being used. Okay. It'll be a fun thing, when you're not taking it, you can practice writing these letters. Okay. Some practice problems now. Find the degree measure of two positive and two negative angles that are co-terminal with 45 degree. Okay. At this point, actually, if you have been paying attention to the lecture so far, you might want to pause the videos and try to do it yourself before I do. I would say that you might feel comfortable doing that, but if you want to wait for a couple of problems to see me doing it, then just let the video play, take notes as you feel comfortable. Okay, so at any point you feel courageous and want to try on your own, pause the video, do it yourself, and then play the video. Okay. So I will begin by first drawing a simple sketch. X-axis, Y-axis, and 45 degrees exactly in the middle here. And what would be a positive angle coterminal to it? I'll make another full rotation, and you can do it like this, okay? In your calculator, take 45 degree and add 360 degree to it. You get another positive angle. So that would be 405 degree. And then you add another 360 to it. And you can do it mentally actually. 765 degree. Okay. And this is addition. If you want to get negative angles, you take 45 degree and subtract 360 degree. Okay. Now if you do the subtraction here by following the rules, that becomes 14. So you subtract 6, get 8. And that becomes you have borrowed 1, so it will be no, it doesn't work like that. I'm sorry. I guess I did some funny thing about basic subtraction. Use calculator, okay? Most of you will do that. I would subtract the other way around. From 360 degree, subtract 45, you get 315. But now you write the negative value because you are doing the subtraction the other way, right? Negative value with negative 315. And then add another 360 from it. And that will give you 675. Okay. All right. when you are taking the notes in this note taking guide, please don't forget to write your name, okay, on the top of every page. Okay. Determine whether the angles are coterminal, right? And what should happen? If they are coterminal, they should differ by 360 degree. So let's say I take that minus 368 degree is coterminal with, I will take that minus 368 degree and add 360 degree to it, right? I'm trying to see, if I can get to that 8 degree. But when you do this addition, clearly you can see it is minus 8 degree. Now, minus 368 degree is coterminal with minus 8 degree. But that minus 8 degree is not going to be coterminal with 8 degree, right? Because if you add another 360, you are going to go 352. That's way more positive, And to get a better sense here, you can actually even sketch them. So we are basically talking about these two angles. The negative 360 degree is like clockwise 360 and another 8 degree clockwise. Small angle, something like this, 8 degrees. Okay, so that is negative 368 degree. Whereas 8 degree is anti-clockwise. If you measure it like that, that's 8 degree. So they are not coterminal. Okay. Answer here is no. Okay. Next question. Name the quadrant. So you have negative 1230 degree. First, second, third, fourth, in which quadrant is it? Now that's a large angle. What you do? You could add 360 to it, right? So try to see when it becomes some smaller value, so you can decide the quadrant. But if you are little think ahead, you will realize that just adding 360 is not going to make it. So I will multiply this by 2 times, and I'm sure that also is not going to be sufficient. I will do it 3 times. Let's see if that gives any hope. Okay, and you can do that on calculator. Let me just work it out here by hand. That I know is 1080 degree. Okay, 900 plus 180, 1080. And now I have negative 1230 and plus 1080. So 1180, 1230. So I can see that's negative 150 degree now. Okay. At this point, you can determine the quadrant by sketching it if you want. Or if you want to add another 360 degree, so it becomes positive, that is also fine. Both ways it works. Okay. So negative 150 degree would be, you start on the positive side of x-axis and you rotate 150 degree clockwise. And clearly you can see that negative 150 degree will bring you to this quadrant, because negative 90 degree is the negative y-axis and then 60 degree more. Not quite the way I drew it, but in that quadrant. So clearly that is first, second, third quadrant, right? So the answer is third quadrant. Okay. Find the negative angle between 0 and negative 360 degree that is coterminal with 190 degree. Okay. You can do this analytically or graphically. Now you could draw a graph and then use that as an intuition, which is generally advisable. Okay. So you have less chances of making a mistake. You have 190 degree, which would be 180. Remember, one straight angle would be 180 degree plus 10 degree more, right? So let's say here, that is your 190 degree. Now you have to find a negative angle between 0 and negative 360. So we're talking about going clockwise. Now what's the measurement? This small angle here is 10 degree, right? 180 plus 10. So which means what is left here should be 170 degree, because total has to be 180, but we're going clockwise here. It's negative. Okay, so the answer is negative 170 degree. And there's going to be only one angle. Okay, that's why the question says the negative angle. Between 0 and 360, there is going to be only one coterminal angle. Okay. Find the degree measure of the smallest positive angle that is coterminal with 540 degree. This time, let us do it just analytically without a graph. Okay. This is a positive angle, but it's more than 360 degree and it's a large angle. I want to get it down. Okay, so it becomes the smallest positive, but it's coterminal. And what do I do? I will take that 540 degree and subtract 360 degree repeatedly until it becomes less than 360 degree. But I think it's going to be done with just one subtraction, because you will find that this will be 180 degree, which is less than 360 degree. So we're good. That's your answer. Okay. If that result was more than 360, you will subtract it one more time and one more time. I think by this time we have enough idea on the positive, negative angles and the concept of coterminal and how to play around, and find them, how to draw the graph and understand and everything. Okay. Moving on. Although 1 degree itself is a very small angle, okay, but for many, practical applications, and especially if we are talking about measurements of some large real world objects, even a small angle difference is significant. Okay, so just 1 degree is not sufficient for precision. You have to divide that degree into further parts, and luckily for us, the division of degree into smaller units is easy. 1 degree is 60 minutes, just like 1 hour is 60 minutes in time. 1 degree is 60 minutes, and we call it minutes. Okay, that is also the measurement of angle, and that's the notation. 60 minutes, read as 60 minutes. Okay, and 1 minute is 60, that double apostrophe, or not exactly apostrophe, prime notation, so double prime, and that is 60 seconds. Okay, so that is the conversion. Now let us use that to do some conversions here. Convert to decimal degrees. That means the angle is given as degrees and minutes. Now you convert it to decimals, but in degree. What is the idea? The idea is 45 degree and 6 minutes. That is how we say. Like, think of it like as time, right? 1 hour and 6 minutes. If someone asks how many minutes is that, 1 hour and 6 minutes, you will say 1 hour is like 60 minutes and 6 minutes. So 60 plus 6, 66. In the same way here, what is 45 degree and 6 minutes in degrees? You would say that is 45 degree plus 6 minutes. That is the meaning of 45 degree and 6 minutes, right? Plus 6 minutes. And then you see that 1 degree is 60 minutes, which means 1 minute is 1 over 60 degree. That's the idea. To convert from minutes to hours, you divide by 60, right? So to convert from minutes to degrees, divide by 60. And clearly that's going to be 0.1. So that is going to be 45.1 degrees when you add. Okay. In the same way, this is 44 degree, 19 minutes, but you divide by 60 to convert it into degrees. And then 32 seconds. So the first time you divide by 60, it converts to minutes, right? 32 over 60 minutes. You divide by another 60. So remember, both the 60s have to go to the denominator. 60 times 60 in the denominator. Now it is in degrees. You can do 3600 directly if you want to remember it that way. Okay. I hope you get the idea. If not, always reach out. We can discuss. Okay. And now this is going to be calculator work. Okay. Towards the end, I think I'll pause the video and I will do all the calculations and write the answers here. Okay, so I will not take your time in the video. I'll come back to that at the end of the whole recording. Okay. Convert the angles to degrees, minutes, and seconds. Or give me a second. Okay. Sorry, I changed my mind, and I thought many of you might be already doing this, right? So why not instantly verify it? You should do this, okay, on your calculator and make sure that you also round it up correctly so your answer matches with mine. Okay. All right. Convert the angle to degrees, minutes, and seconds, and you have 17.8 degrees. Now we're doing the reverse, right? We're going from decimal degrees to minutes and seconds. Now, reverse engineer the whole process. This is 17 degree plus 0.8 degree. Right? So the degree part we are fine, 17 degree. What about 0.8? At 0.8, if you multiply by 60, that is now minutes. Right? From minutes to degree, you divide by 60. From degree to minutes, you multiply by 60. And that would be 17 degree. And 8 times 6 is 48. You can do that again in calculator. Okay. 48 minutes. And we're done. See, 48 minutes is less than 60 minutes. So it is less than a degree. So we're done here. Okay. If it was more than 60 minutes, then I would take the degree part out of it. I'll take the 60 multiples of 60 out of it. And the remaining part you can convert to seconds if you want. Or if there was still a decimal, then that decimal in minutes would be converted to seconds. We don't have decimals anymore. So we're done here. Okay. What do we have here? Perform the following computations without using a calculator. Okay, so this is the exercise. First do it, without calculator, and then use a calculator to verify your answers. Okay, so I will now, maybe you want to watch this, me doing it. I'll show you how you could do this by hand. Okay. What is the operation? This angle, 34 degree, 40 minutes, and 15 seconds divided by 3. So you are trisecting the angle, 1/3 of that angle. What would I do? I would do like this. You can do different ways. Okay, I'm just showing you one way. I'll take the 34 and or I'll show you the normal division. Divide by 3, right? And clearly 3 times 11 will be 33. Remainder is 1, right? So this should be 11 degrees plus 1/3 degrees. You have to understand that. Okay, I'm dividing by 3. So that remainder, you have to divide by the divisor. I mean, when you express it here. Okay, so that's 11 degree plus 1/3 degree. And then similarly with the 40 minutes. You are dividing by 3. Let me write the question on this side. 13, clearly. 39. Remainder is 1. So that is plus 13 minutes plus 1/3 minutes. Okay. And then you have plus 30 minutes plus 1/3 minutes plus 15 minutes, 15 seconds divided by 3. That you can understand will be 5 seconds. Okay. So let me change the color. On the right side, we did this scrap work. This is our first step. So how do we simplify it? This is 11 degree. What about the 1/3 degree? That's less than 1 degree. So now what you do, multiply that 1/3 by 60. Get 20. And now that becomes minutes, right? So plus 20 minutes. Okay, 1/3 times 60 will convert it to minutes. And you have 13 minutes there. Plus 1/3 of a minute. Similarly, if you multiply that 1/3 of a minute times 60, it will become seconds. So that we have already seen is 20, 1/3 times 60. So 20 seconds. And you have 5 seconds. Okay. Let us see if this can be written neatly. This is 11 degrees, 20 and 13. 33 minutes and 25 seconds. Okay. Now you can use a calculator to verify. I'm not sure if your physical calculator will have the minutes and seconds option. Search about that online. Okay. All right. Next, addition of these two angles which involve degrees and minutes and seconds. And this one I will illustrate to you like how you do addition of numbers with carryovers. Okay. 8 degree, 22. Okay, there's a typo here. Sorry about that. That's 22 minutes, 28 seconds. Okay, so we'll add that. And how does that addition work? First, you add 28 and this one 8 plus 2, 10, 0, carry over 1. Now 4 plus 2 plus 1 is 70. Okay, maybe in this step, let me do it this way and we'll simplify the next step. Okay, so that is 70 minutes. Similarly here 70 seconds, 77 minutes, 15 degrees. Could we just leave it like that, 15 degree, 77 minutes and 70 seconds? Yeah, technically, but we know that more than 60 minutes is a degree, more than 60 seconds is a minute, right? So what you should do is to write this as 60 minutes and 17 minutes, right? Or if it has a more bigger value, I would have checked, if it is 60 times 2 or 60 times 3, how many ever multiples can go in. Or you can divide. You can divide that 77 by 60 times 1, and the remainder is 17, right? So until you get a remainder which is less than 60, you can continue that division process. So what you get here, quotient, is your degrees. Okay, so that 60 minutes now will become 1 degree, right? This is the quotient here. Okay, and similarly, this 70 minutes seconds can be written as 60 seconds and 10 seconds. Okay, now for some things I will write in different color. This is 1 degree here. This is 1 minute here. Okay, so my final answer is going to be, I'm going to simplify this and write. Give me just 1 second where I can decrease its font size, and so I can write it. Okay, this is going to be 16 degree because 1 degree comes from there, and 18 minutes because 1 minute comes from that 60 seconds, and then you're left with 10 seconds at the end. Okay. That would be your final answer. Okay. Find the degree measure of the angle alpha. Okay. So there is a triangle, with 2 angles, equal angles, alpha. Find its degree measure. What is the logic? The logic is, in this triangle, right? This is an opportunity for us to review also that alpha and beta, when you add, you should get 180 degree. Okay, which means 2 times alpha plus that beta. You can subtract it on the other side now because you know the value of beta, right? So that is now 180 degree minus that value, 30 degrees, 24 minutes, 12 seconds. We need to perform that subtraction, which is an opportunity to show that process, right? So you have 108 degree and you are going to subtract 30 degrees, 24 minutes, 12 seconds. How will you perform this subtraction? This is the same classical method of borrowing, when you are doing subtraction. Now you might want to recall all the basic arithmetic from high school. So this is basically 0 minutes and 0 seconds. Okay. So when you borrow from here to here, that will now become 60 seconds, right? When you borrow 1 minute, it becomes 60 seconds. You subtract 12, you get 48 seconds. You have borrowed 1 minute from here, but that itself was 0 minutes. So you should borrow 1 degree from here. Okay. When you borrow 1 degree, that would have been 60 minutes, right? But from the 60 minutes, you have lent 1 minute to the seconds there. So you have 59 minutes now. Okay, so I'm writing that here. just for my mental calculation. I have 59 minutes here. 1 minute was borrowed by the other side, second side. So 59 minutes minus 24 minutes will give you 35 minutes. Okay. And then you have borrowed one, you have lent 1 degree from here. So you are left with 179 degree. From that, you subtract 30 degree, you get 149 degrees here. 35 minutes and 48 seconds. Okay. So that is 2 alpha. And continuing that over here, that means your alpha will be 149 degree, 35 minutes, 48 seconds divided by 2. Okay. Then you have this second, process of calculation going on. It's a fun, interesting question. Okay. And now you do this division just like what we did with dividing by 3 earlier. Okay. Go ahead and do it by yourself first. This will be 74 degree plus 0.5 degree. Okay. And plus 17 minutes plus 0.5 minutes. Right? I'll write 0.5 so it's not confusing to you. 35 divided by 2 will be 17.5. So 17 plus 0.5. And 48 divided by 2 is 24. 24 seconds. Okay. So 74 degree, all right, no problem. And some work you can do on the side, 0.5 degree now, or 0.5 degree, you multiply by 60. It becomes seconds. And that will be 30. Sorry, it becomes minutes. So that will be 30 minutes. Hence, plus 30 minutes plus 17 minutes. Similarly, plus 30 seconds and 24 seconds. Okay. And now you simplify 74 degree, 47 minutes, 54 seconds. Okay. These are some very good examples that we have done here. So we feel very comfortable with the angles and the algebra of angles, I would say. Okay. In degree measure. All right. And in the next video, we will talk about the radian measure. I'll see you there.